Alright, now let's take a look at the algorithm to solve the action prediction in a fighting game. So we're going to start from the first step. We have seen this in the last video, so now we are going to check the next step. So here we have a latest strike that we assign to M. So M is the latest strike the player has made. Now we are going to have two cases that we need to check, and the first case would be that either A or B is unknown. So what this means is that we didn't know what is our first strike, or we don't know what is the second strike. Therefore, we are unable to make a prediction if we do not have sufficient number of strikes. So in this case, how do we update our frequency data? So what we do is we first increment n total by 1, because we have already obtained a new strike from the player, so that should increment the n total by 1. Now, if A is unknown, that means if I found that I don't know any strike that the player has made so far, then you have to set the A strike to M. So that means A will store the latest strike in the case where A is unknown. Now in the case where B is unknown, now this means that you already have at least one strike that you have observed previously, and you have stored it in A. Now if this is the second strike, if the latest strike M that the player has made is the second strike, then you want to assign that to B. And what you do next is you want to increment n A union A intersect B by 1. The reason for doing this is because we already know what is the first strike and what's the second strike. Therefore, we will know we will be able to increase the number of occurrence for A and B. So does not matter which whether A is unknown or B is unknown, you will want to return a random strike, because at this point you cannot predict what is the next strike yet. So you will just choose a random strike and you just return it to as your prediction. Now in the second case is where you have the sufficient information to make prediction. So this is the case where both A and B is known. So given the fact that you already know the previous two strikes, so what you are going to do when this is the case, what you do is we will increase the n total by 1, because the latest strike will increase the number of strikes so far, and you also would want to increment the number of the frequencies for A intersect B intersect C, right? Where in this case C is really the current strike that you have seen in M, right? Then after that, what you do is you update your A/Bs so that you would actually have to switch the strike for in B. You want to assign that to A, and after that you put the new strike M to B. So these two lines essentially remove the very first strike that you have made, because you want to predict using the latest two strikes that you have obtained so far. So once you have done this, then you want to increment A intersect B by 1 to update a new number for A intersect B. So after that, what you want to do, this is where you compute the probabilities to make predictions. So you compute the probabilities PC equals to X given the fact that A and B occurs for every possible strike X. Now what this means is that X is X can be any 3 strikes that that's available. X can be a punch, it can be a low kick, or it can be a high kick. So we're going to calculate at least 3 probabilities given the fact that A and B has occurred. So how to calculate the probabilities for this? So here comes the equation that corresponds to the conditional probabilities A and B given probability of C equals to X given A and B. So this one is equivalent to getting the number of elements in this set A and B and C equals to X, and that's divided by A and B. So once you have calculated all the probabilities, you want to find which one has the highest value, because that will tell you which strike is the most probable strike that the player would use later on. So hence the predicted strike X is a strike X such that P C equals to X given A and B is maximum. So then after that, what you do is you will output the predicted strike. Now in the event where there are more than one maximum when you calculate these probabilities, then you can randomly output any strike that has the maximum. Okay, so this is the general solution for action prediction in fighting games. Let's see a concrete example that will illustrate this in detail. So here we have an example where I labeled P as punch, L as low kick, and H as high kick. So here are 2 tables that actually tabulates the value of N A intersect B, where A can be any of these strikes and B can be any of these strikes. So this is actually a 9 times 9 table that stores the occurrence, number of occurrence given of A equals to a certain strike versus B given a certain strike. So for example, this value right here corresponds to the number of occurrence where the previous first strike is L and the previous second strike is P. So what is the value? How many occurrence of that? How many times this occurs? Then we have this table which shows the number of occurrence for a combination of 3 events. So this one will have a 9 times 3 values. So this on these rows it actually shows the possibility of A equals to P and B equals to P, and you have 9 combinations. These combinations coming from these 9 over here, and here we have C. C is actually the predicted move, and C can be any of these. Now in actual fact, C can also contain an unknown strike, because it is possible that at the beginning, when we only have 1 or 2 strikes stored from a player, then it is possible that C is unknown, because there's a chance where we do not know what is the where we don't have any prediction of the next strike the player will move. So therefore there's a chance that C is unknown, but because due to the limitation of our slides, therefore I can't put numbers for that. But you can imagine that this C equals to unknown in all cases. The number is just going to be 1 at most, right? Because this one only happens at the beginning of the prediction. Then here we have this N total, which initially is going to be 0, because this is when we have not seen any strike from a player. And A and B is also unknown because we haven't seen any strikes yet. Now what happens when we see strikes coming from a player? So let's move on to the next slide. So now where M is L, so M is actually the latest strike that the player has made, and the latest strike is L. So L is actually a low kick. So when the player has made a strike, then what happens is that we know that we fall on the first case because at that point A and B is unknown. So what we do is, when in that case we want to perform the necessary updates for case 1, and that means we want to update the N total to 1 because we have seen one strike, and then we want to store that strike as for A. That means we are collecting what we observe, and because that is the first strike that we have seen, so we store that as A. Then we return a random strike as our prediction. When the user makes a second strike, and assuming that the second strike is also a low kick, then notice that before this B was unknown, and so this is still a case 1. So to perform a necessary update, what it requires is that we have to assign B to L to store what we observe. And another update is actually this value here, which is N A equals to L and B equals to L. The reason we update this is because we have seen a combined case where the first strike is L and the second strike is also L. So we update this to 1. And again, in this case, we can only return a random strike because we cannot make any prediction yet at this point. Now, here comes the part where we're going to return some prediction. So, assuming that the third strike coming in from the player is a high kick. So, in this case, we know that we have 3 strikes already, so we are moving into case 2. And so, before we switch our A and B, we have different ways of updating the table, which you can see that for red colors. First thing what we do is we update the N total to 3. We increase the N total. And the other update is actually occurring here. You update this value because you have seen a case given the fact that A is L and B is L. So there's an occurrence for C equals to H. C is your third strike now. So this combination of L, L, H, you have seen it, and therefore you update it with a 1. So this is what you do before you switch A and B. That means you have not update A with the values of B, and you have not updated B with the values of M. Now, after you have done the update, which in this case A changed from L to L, this L gets from B, while B changed from L to H because it get it from M. Then this is where we can make a prediction. So before we make the prediction, first we update the fact that we have observed that there is a case where A is L and B is H. So this is the case for the last two, right? Last two. So we increase this value because the number of occurrences for A equals to L and B equals to H, we have found one case, so therefore this is updated. Then what we do here is we have to return our prediction. So how do we predict? So what we predict is we refer to this table for the entry where A is equals to L and B equals to H, and we want to see, we want to compare all these, we want to take all this value and calculate probability. So how do you calculate probability? You actually take 0 and then you divide it by this value 1 minus 0, and you do the same for the rest, and you will find that actually you still have to return a random strike because each of these probability is the same. So therefore you still return random strike in this case because there is no strike here that actually has an advantage. Right, so in the next video we are going to continue from this example, and then we will talk more about what happens when more strikes come in. Right, see you later.